Okay, first lesson, Year 10, Ignite Maths. I am teaching you how to solve linear equations. So remember, in black, that's not notes. If you're fast enough at writing, get it down. But this is just to help me explain to you what I'm saying. What is a linear equation? It's one where the variable, usually x, is only raised to the power of 1. You need to be able to solve these with the following steps. So if you don't already know this, if you don't trust your ability to remember it in a pressure time of a test, this is what could appear on your cheat sheet. Every test this year that we have, you'll be allowed a cheat sheet. One-sided, A4 handwritten. So what's the first step? Identify all the terms and how the equation has been built in BEDMAS order. Can someone remind me, what does B stand for in BEDMAS?
Brackets.
Good. What does E stand for?
Exponent.
Exponent, so that's a power. D,
Division.
M,
Multiplication.
A,
Addition.
S.
Subtraction.
Now, I'm not the authority on everything. I couldn't teach you from primary school, but if I could fix everything, BEDMAS should actually look like this. B, E, D, M, A, S. What do you think that slight change to it means in this context? Yes?
It's because division and multiplication are in order of how the equation
Good.
works.
Okay? The problem with teaching you BEDMAS, and I'm not hassling your primary school teachers or any like year 8 and year 9, that they just want a nice word to talk about. But this, do you think some lesser thinking people might think the division always has to go first? Because it's first here. But no, what the reality is division and multiplication are equally as important. And addition and subtraction are equally as important. How do you decide which to do first? You just go from left to right, okay? If you're deciding between division, multiplication, addition, and subtraction. They're equally as powerful, all right? I'll give you time to write after these steps, all right? Step 2, after you've worked out how it was built up in BEDMAS, you perform inverse operations on both sides of the equation to remove each term in reverse BEDMAS order. What does that mean? What's the inverse? What's the opposite of adding something? Good. What's the opposite of multiplying something? Good. So if you've decided that something was achieved by adding, to get rid of it, I need to take it away. And I need to do it to both sides, otherwise I'm changing the question. So that's what step 2 is about, and you must do it in reverse BEDMAS order. Any ideas why I must do it in reverse BEDMAS order? Okay, if I was building a house, I'd build a foundation, and then the walls, and then the roof. Because if I build the house any other way, is it going to work if I build the roof first? No? It's going to fall. So if I've got an equation that was built a certain way, I need to do it in reverse to break it down. Because if I broke down the walls, what's going to happen to the roof? It's going to fall on you. That's why you need to do it in reverse BEDMAS order. There's an explanation for everything. And then lastly, you repeat step 2 until the variable is isolated. The letter is by itself on one side. If you've got the time to check, if you want to flex on everyone. If you have time, check the solution by substituting what you think x is into the original equation and show me that you are right in the first place. Okay? I'll give you a couple of minutes of writing time to get down to there. And I'll show you some examples. My YouTube not entertaining enough for you guys. No subs from this class yet.
I actually saw the one.
You did? Haven't got any notifications.
And I've been watching your growing video. I'm 26 minutes in.
It's just me breathing heavily, sweating. You'll probably experience the thing that all students have when they meet for the first time. Your hand starts hurting after writing so much. Yeah, cool story, bro. Your tests are written, so you need to be able to write. some of you still writing, it's okay. It'll be saved for perpetuity on YouTube, unless Google fails somehow. Let's have a look at this. Let's apply those steps. 3x plus 7 equals 22. Identify all the terms and how the equation has been built in BEDMAS order. This is a term. I multiplied x by 3. This is another term, plus 7. I added 7 to the answer, and it equals 22, another term on the other side. So what would be done first if I was working this out? I'll do the multiplication first, and then I would add 7 to it, and then I have my answer. Okay? So we have just done step 1. I identified the terms and I worked out how it was built up. Step 2, perform inverse operations on both sides of the equation in reverse BEDMAS order. So if you want a reminder, write BEDMAS and draw an arrow pointing the wrong way to show what you need to deal with in reverse BEDMAS order. Is there a subtraction here? Yes? Not yet. He's skipping over. That's what Ignites tend to do, yeah? But let me tell my story and then so that people can see the steps up. So there's no subtraction right now to break down. Is there an addition in this equation? There is an addition, it's plus 7. So what's the inverse of adding 7 to something? Subtract 7. So rewrite this, plus 7. Okay, I haven't written anything different, but now I write take 7, I put it in a little box, equals 22. What does this say? I need to do it on both sides. So what did I put in a box on one side? Take 7, so I also need to take 7 on the other side. Why do I like doing the box? Do I have a box on both sides now?
Yep.
So it's balanced up. It's the same on both sides. So the next line would be actually doing that. 3x. What's plus 7 and then take 7? What's going to be left? Nothing. So just leave it. You don't need to write 0. And what's 22? Take 7. 15. Okay, so we've removed one term. I need to deal with the last term. We just dealt with the addition. Is there a multiplication in the situation? Yes, it's 3 times by x. So I'm going to deal with that. What is the opposite of multiplying something by 3? Divide by 3. So divide that by 3. I need to divide the other side by 3. What's 3 divided by 3 going to give you? But why does it give you x? Someone else. What's 3 divided by 3? Just
1.
1. Good. A lot of people say 0, but that doesn't help you because then 0 times by x would disappear. So it has to be 1. So x is going to be, what is 15 divided by 3? 5. That's your answer. Little box around it. If you wanted to flex, like I said, if you have time, check the solution by substitution. Well, 3 times by, I just worked out that it was 5, plus, not equals, plus 7. Is that a true statement? 3 times by 5, is that 15? Is 15 plus 7 22? I've confirmed that it's true. I flexed on you. I must be right. Okay? Next. I'll go through this, give you time to copy down, and then I'll let the video run because there's one more example on the other side. We've got 1, 2, 3 terms again. What would happen first? The divide by 3 or the add 2? In constructing it. So building it in the first, it's fine. We're fixing that over time. Division happens first. If I was working this out, addition would happen last, and then this is just by itself here. So, reverse BEDMAS order. Is there a subtraction anywhere? No. Is there an addition? Yes. So x on 3 plus 2, take 2 is what I'm doing. Take 2, take 2. What's plus 2, take 2? What's going to be left?
Nothing.
Nothing. X on 3 is equal to, what's?
4.
Minus 4. A lot of people have trouble with their negative numbers. If I'm at negative 2, I'm going further negative by 2. I'm going to be at negative 4. So I'm at x on 3 is equal to negative 4. What is the 3 doing to x? Divide. Good. What is the opposite of dividing something by 3? Times by 3. So you go times by 3. Times by 3. 3 over 3 is just going to leave you x by itself. What's negative 4 times by 3?
Negative 12.
Negative 12. So answer you want to flex on people, you think that x is negative 12, so you go negative 12 on 3 plus 2 equals, what is negative 12 divided by 3? Negative 4. Add 2 is going to be negative 2. So you just prove to yourself that you don't have to do this. This is just a check if you've got time. Get those examples now? Give you until 10:2. And I've got one more example on the other side. Don't say anything yet because that's running. Does this look like some kid dropped an eraser? Anyone want a free eraser? Oh. You rock, paper, scissors. You rock, paper, scissors. Did you have your hand up? You won? You won? Okay. Did you just swear? No, she has an obsession with sheep. It's okay. All right, last thing. Is that on there? This is not any different to what you've done, but it's an extension. You have to be able to deal with equations that have a repeated unknown. Sometimes an equation will have unknown in multiple terms. How many unknowns do I have here? 1. How many unknowns do I have here? Only 1. I need to give you techniques for dealing with more than one unknown. So if present, expand any brackets and collect like terms. That's step 1. Step 2, use inverse operations like before. Step 3, solve the equation as normal. Sorry, step 2 was use inverse operations. You want to get the unknowns onto one side. And then you solve the equation as normal. You alright? You're staring into the middle distance. Solve for x here. Is there a set of brackets here?
Yeah.
I need to expand that. So I'm hoping in year 8 and year 9 you were taught there's a 5 on the outside. I need to multiply that with this. And then I need to add 5 multiplied by this. That's how I expand the bracket. So what is 5 lots of x? How many x's do I have if I multiply by 5? 5x. What is 5 times by 1? So I've got positive 5. I didn't do anything with the negative 2x. So I leave it. Equals negative 7. Did I just expand brackets if they were present? Can I collect like terms? How many x's do I have here? 5. And I'm taking 2 x's. If I've got 5 bananas or x's, and I take 2 bananas, how many bananas do I have? 3. I have 3 x's. I didn't do anything to the plus 5. Take 7. Now we have literally the same situation as on board 2. What would I deal with first? Timesing by 3 or adding 5? I need to get rid of the add 5 because in reverse BEDMAS order is addition over there. What's the opposite of adding 5 to something? Subtract 5. Take 5. What's 5 take 5? So what's going to be left on the left hand side? No, 3x plus nothing. So you're going to have 3x is equal to, what's negative 7? Take a further 5.
Negative 12.
Good. I'll put my working out over here. I'm not going to flex on this one. 3x is equal to negative 12. What is the 3 doing to the x? What's the opposite of timesing something by 3x? Good. So you're going to go 3x and you're going to divide it by 3. And to keep it balanced on the other side, I'm also going to divide that by 3. What's 3 divided by 3? 1. So that's going to leave you 1x or x. What's negative 12? What's 12 divided by 3 normally? 4. But because it's a negative 12, what kind of a 4 is it going to be? Negative. Let me do like a semi-flex. You've got negative 4 plus 1 is going to be negative 3. Negative 3 times by 5 is negative 15. Negative 15 take... Negative 15 take positive, because negative 2 times by negative 4 is going to be positive 8. You'll get negative 7. Alright, can you get that example please? And then you've got 20 minutes solid to do exercise 5A1, 5A2. So your homework now to end of EX 5A.1 and 5A.2. I'll get some books out so you can share them.
It's not on the numbers well.
I've got a PDF of it on Daymap, but I've only kept that just for this lesson. I can't give you the whole book, I'd be in trouble. Although actually I'd be covered because I literally bought like 30 of them, but I still don't want to do anything. You can use the PDF on Daymap actually for now, just for this topic. And then later,